Okay, so we've already looked at fractional distillation, which is the separation of hydrocarbons using their differing boiling points in a thing called a fractionation column, which allows the fractions to come off as separate groups. Now, once we've done that, there's a processing that goes on with the chemicals because only some of the hydrocarbons are actually useful. Now, what we want with alkanes is for them to be short chain because short chain alkanes are more flammable and they're more volatile, so they're more useful inside engines as a fuel. As well as that, we can do with using alkenes for things like making polymers and making pharmaceuticals. So in order to achieve both of these, what we can do is a process called cracking, which is where we heat up the longer chain alkanes that we get from the fractional distillation with a catalyst. And catalysts are a chemical which is not used up by the reaction, but which help to aid the reaction to occur in the first place. And the combination of the heat and catalyst breaks the molecule into two smaller sections. So you can see here that the long chain alkane, which is actually octane, because there's 8 carbons there, breaks between the third and the fourth carbon if we count from the right. And that forms an alkane and an alkene. And it's a shorter alkane than it was before, so it's more useful. And the alkene is more useful as well because we can use it as a building block molecule because of its unsaturated carbon-carbon double bond. It's quite easy to do addition reactions with. So this process is really useful in the processing of crude oil to turn what we initially get into even better, more useful products.